Okay, so let's calculate the coefficients bk. Now this has the same kind of form, except instead of having the cosine of kx in the integrand, we have sine of kx. We have the same trick as before. We can just integrate from 0 to pi, since our function f of x is equal to 0 between pi and 2 pi. Okay, so because we have that 0 here, there's no contribution to the integral between pi and 2 pi. So that integral between pi and 2 pi is equal to 0. So this lets us rewrite our integral as 1 over pi times the integral from 0 to pi of x squared sine of kx. Okay, now we have an integral with a product of two unrelated pieces. So again, we're going to use integration by parts. Polynomials, we prefer to differentiate compared to trig functions. So u is going to be equal to x squared. dv is equal to sine of kx. We differentiate x squared and we get 2x, and we differentiate again, we get 2 and then 0. And sine of kx integrates to negative cosine of kx over k. And that integrates to negative sine of kx over k squared. And then we integrate that to cosine of kx over k cubed. Okay, so our integral is 1 over pi times, well, we have x squared times negative cosine of kx over k. So we get negative cosine of kx times x squared over k minus 2x times negative sine of kx over k squared. So those two minuses become a plus, so I get plus sine of kx times 2x over k squared. And then we have plus 2 times cosine of kx over k cubed. And we're evaluating between 0 and pi. All right. Now, just like last time, right off the bat, we know we can ignore this middle term because we know that sine of k pi is always equal to 0. Okay, so that term is always going to just be equal to 0. And now we can plug in pi and 0. So I get 1 over pi times negative cosine of k pi times pi squared over k plus 2 cosine of k pi over k cubed. Okay, and this is minus, well, when we plug in 0 here in this x squared, our term is equal to just 0. So we get minus 0 plus 2 cosine of 0 over k cubed. Okay, all of this is multiplied by 1 over pi. Okay, so this simplifies down to 1 over pi times negative cosine of k pi times pi squared over k plus 2 cosine of k pi over k cubed minus 2 over k cubed. Okay, and so for us we have that v1 is equal to 1 over pi times negative 1 times pi squared over 1 plus negative 2 over 1 minus 2 over 1. Okay, so the first term we end up with is 1 over pi times pi squared minus 4, which we can simplify down to being just pi minus 4 over pi. B2 is equal to 1 over pi times negative 1 times pi squared, so we get negative pi squared over 2 plus, so I have 2 over 2 cubed minus 2 over 2 cubed. Okay, so these terms just cancel out. So I'm left with 1 over pi times negative pi squared over 2, or negative pi over 2. And finally, B3 is equal to 1 over pi times pi squared over 3 minus 4 over 3 cubed, or pi over 3 minus 4 over 3 cubed times pi. All right, so we've got all of our coefficients. We can now put them all together, and we'll look at some pictures of what these partial sums look like.